plane in space. Okay, plane in space. Okay, plane in space. And what do you need to understand? Basically, plane is kind of any surface. Okay, either that surface is in uniform shape. For example, this kind of, you are having your floor, okay, your ceiling, your wall. That is actually plane. Your what we call it? Okay, body of your car. That is also plane. Okay, plane. Okay, and sometimes they are also in the non-uniform lah. Of plane can be like this. Okay, still plane as long as you are having uh I can say 2 dimension lah. It's not, yeah, supposed to be 3 dimension. But normally our plane is depends. We are having a very thick plane. We are having very thin plane. Okay, so that should be referring to our plane. And the application regarding to this plane very broad lah. Okay, so okay, what we want to study here. Alright, and before I proceed, okay, so in this lecture, I will represent our plane as pi. Okay, the symbol pi here represent our plane. It's not pi here is 3.4142. No, okay, it's not a constant. This is just symbol to represent our plane lah. Let's say pi 1 here, pi 2. Okay, if you refer to our textbook written by our seniors, okay, Tuan Haji Abdul Wahid and also friends, okay, his friend. So they are using pi to represent our plane, okay. So please, it's not constant. Okay, so I proceed to the first topic here. Okay. Okay, as usual. Okay, equation of a plane. How do we get the equation of our plane? Basically, equation for the plane comes from our dot product. Okay. Yeah, dot product. So let's say, okay. For now, I'm considering just the shape of plane. Okay, I'm using this one. Okay, let's say we are having our plane. Okay, let's say this is our plane. So if you know a point on your plane, okay, a point on your plane. For example, this is your point P once again, and x naught, y naught, z naught means that this is known. Okay, known point and located on the plane. Okay, and then we are also having arbitrary. Okay, arbitrary point Q. Okay, similar as our line in any location or okay located on the plane. So let's say I choose Q here, maybe Q located here, maybe here, maybe here, maybe very close to P. But let's say for this example, just for this illustration, okay, explanation here, so I'm considering Q here. So this is actually arbitrary. Okay. And then, okay, all surfaces, okay, or in simple say, all planes should having normal vector. Okay, either your normal vector okay goes to the top here like this, not straight line. Okay, normal vector or normally written as n lah. Okay, normal vector, or goes down. Okay, because we are having two direction of normal vector. Let's say here n1 and here n2. Okay, n1 and also just opposite direction. But still both represent the normal vector to this plane. Let's say I denote this plane as pi. Okay, plane pi. Okay, so if we are talking about normal vector, means that normal vector always perpendicular to our plane. Okay, it doesn't matter whether you are having a flat plane or a little bit curve like this. So if you are having normal vector here, must be perpendicular to this point. Okay, at this point. So same goes to here. Okay, this is also must be perpendicular to this point. So that we are having normal vector, normal vector. Okay, in this case of a little bit a curve, okay, curve surface. Okay, so you are having a different normal vector. Okay, but I'm not focusing in this kind of situation. So I'm just referring to, let's say we are having just flat plane, so we focus with just one normal vector. Okay, of course lah, basically we are having two, but different direction lah. Okay, so if we can get a vector between PQ here. Okay, so let's say this vector PQ, once again, Q can be anywhere. The most important on our plane. So we can get our PQ. Let's say we are using x0, y0, z0, and also x, y, z itself lah. And we know that the relation this vector PQ with our normal vector here, let's say n1 here, so is strictly 90 degrees. Okay, perpendicular. Okay, from this relation perpendicular, so you can derive your equation of a plane. So let's say PQ, okay, PQ is perpendicular. So perpendicular, I'm writing in this form. Okay, perpendicular to our normal vector. Let's say I'm choosing a normal vector 1 lah. Okay, same goes to normal vector 2. And this normal vector, let's say we know the value. Still, I'm using ABC, but now for plane ABC here referring to normal vector. Okay, in line ABC referring to vector parallel to the line. So you have to be clear. Okay. So when this is perpendicular means that by using our dot product, okay, property of our dot product, so we know that PQ dot normal vector 1 should be equal to what? Equal to what?
0.
0, yes, exactly 0. So you can get what is your PQ? Okay, Q minus P. So you get X minus X naught. Okay. Here y minus y naught, okay, and z minus z naught. That is actually a vector for PQ. And what is your n1? So let's say we use ABC here. When you perform this dot product, so you get a x minus x naught plus b y minus y naught plus c z minus z naught. Okay. Next, if we expand, because A, B, C, x naught, y naught, z naught are known constants, known values, okay, except for x, y, z itself, because x, y, z unknown okay, point of Q, because this is arbitrary, can be anywhere on this plane pi. Okay, so if we expand this equation, so we can write in this form ax plus by plus cz. Okay, and then we put a multiply x naught negative, so I bring to the right hand side, so we get positive ax naught. Same goes to by naught, so negative bring to the right become positive by naught, and the last one plus cz naught. Okay, and since ax naught, by naught, cz naught, you know all the values here, so that you can get just a constant to represent ax naught, by naught, cz naught here. Okay, and let's say I'm writing this constant, known constant, as d. Okay, if we write as d, means that your equation now become ax plus by plus cz equal to d. This is our equation of a plane. Okay, for example here lah, plane pi. Where is it? Plane pi. Okay, so go back. In order to write this equation of a plane, we need to know two information, two values. What are the values that we should know here to create this equation of plane? What are the values? that you need here? What is it?
Normal vector.
Normal vector first, yes. The second one?
Point on.
Point on the plane.
Okay, 1 point at least, at least just 1 point enough. Okay, a point on the plane. Okay, so in other words, first you need, so I'm writing, okay, maybe we focus with one. Okay, one here, two here. Okay, point on the plane. And the second one, perpendicular vector to the plane. That is actually our normal vector lah. Okay, normal vector. So I'm just using perpendicular. Okay, because some of the question they are not mentioning about normal vector. They are using perpendicular vector instead of normal. So you should know lah. Okay, normal is actually perpendicular vector. So if you are having both informations, okay, then you may create this. You may get this. How? You substitute lah. Okay, ABC. You can take ABC directly from the normal vector. You put it here, multiply to x, y, z. Okay, because x, y, z should be unknowns. Okay, and then here right hand side, you just multiply A with your x naught, B, y naught, C, z naught, and then you sum all three, and then you get your constant D. So you get at the end your equation of plane. That's how to create this equation of plane. Okay. Now reverse. If they give you equation of a plane here, what kind of information that you may extract from this equation of a plane? What is the information that you can extract from here? If you are having this equation of plane, what is it? Can we get our vector vector perpendicular to the plane from here? Is it possible?
Yes, sir.
How? How?
A, B, and C.
Okay, good. Okay, if you see clearly, A, B, C here are the vector parallel, represent our vector perpendicular to the plane, our normal vector. So means that if you have any constant in front of x, any constant in front of y, any constant in front of z, you combine all three here, you get perpendicular vector to that plane. Okay, so you can get normal vector A, B, C. My next question, can we get a point on this plane from this equation? Is it possible? Let's say if you are having just 10, let's say 10 here. Is it possible you can get your point on the plane? Class, is it possible?
Possible.
Possible, are you sure? Okay, so if you are having this equation of a plane, information that you can extract is just regarding to normal vector only, because you can see clearly from the coefficient of x and also y and also z. But how do we get our x naught, y naught, z naught point on the plane? That's impossible. Okay, from this equation because okay, if you want to identify x naught, you want to identify y naught, you want to identify z naught, you have three unknowns. And if we equal this term with D, so you can see lah here, A x naught, B y naught, C z naught equal to D. Maybe this is known. A, B, C also known, but we don't know what is x naught, y naught, z naught. You have three unknowns, but just one equation. Is it possible to get x naught, y naught, z naught? Now, possible or not? Class?
Not possible.
Not possible. Okay, because you have three unknown. At least you require three equations. Okay, 3 equation. Except you have another alternative technique. For example, you assume x naught, y naught, 0 and 0. Then you can get lah what is your z naught. But that is based on try and error. You assume. Okay, or maybe you assume x naught is 1, z naught is 0. So you can get y naught value. Okay, that's the other things lah. Okay, but in general, if we want to find 3 unknowns here just from one equation, that's impossible to get all the unknowns. Okay, except you assume some of the unknowns here be any particular value, then that's possible lah. Okay, all right. Okay, so this is equation of plane. So I just proceed another thing is, okay, because for the plane we are having a little bit many things that we need to consider. Okay, B. Angle, I go for angle first. Angle between two planes. So once again, let's say I'm considering just rectangular planes lah, okay, flat planes. So let's say we are having this plane. Okay, and then we have another plane here. Okay, and that plane intersect to each other. Let's say I extend to the back. Okay, and the second plane I extend okay down here. Okay, this is your first plane. This is your second plane. Okay, simple example, your wall and also your ceiling, or your wall and also your another wall here. Okay, or your wall with your floor. Okay, that's actually one example, a simple example that you can imagine lah. Okay, you are having two planes. Just a moment. Okay, so let's say we are having okay, later. Okay, so when we are talking about angle, okay, angle means that between these two planes, referring to this angle, theta 1 for example, or angle at the back here, theta 2, or angle down here, or angle at this side. Okay, all are about angle between two planes. Okay, so must be theta 1 and theta 3 here similar. Okay, you can imagine lah if you are having this textbook, this book, you extend a little bit, go down here. Okay, this angle should be similar to angle here. Okay, angle here should be similar to angle somewhere here if you extend. Okay, so that's why theta 1 similar to theta 3 and theta 2 similar to our theta 4. All is about our angle between two planes, either one. But as usual, as our line in space, so we are interested in either we are getting obtuse or acute angle. So means that for this case, let's say I consider theta 1 or theta 2 lah. Okay, theta 1, theta 2. Okay, that's angle between two planes. But if you want to apply the or cross product, okay, normally we apply dot because that should be easier. Okay, so if you want to use dot product, okay, means that you require two vectors. If you are not having any two vectors from your plane here, that's impossible for you to get this theta unless you are having another approach. But we are talking about dot and also cross here. Okay, so we need two vectors. Can we get two vectors from plane pi 1 and also plane pi 2? Is it possible?
Sir,
What kind of vector that you can get?
the vectors perpendicular to these planes.
Okay, good. Vector perpendicular to this plane. Okay, means that here, for example, I'm drawing this. Okay, this vector perpendicular to our plane pi 1 and this vector perpendicular to where is it? Okay, a little bit somewhere here. Okay, N2 is perpendicular to our plane pi 2. Okay, so we are having these two planes and also two perpendicular vectors to the both plane lah. Okay, let's say N1 and also N2. So my question, between this N1 and also N2, if I'm having this theta, is it this theta represent our angle between two planes?
Yes, sir.
Yes. Okay, yes. But okay, this theta. Okay, this theta. This theta similar to theta 1 or theta 2? For example, I delete the other two here. Okay. Next, my question is this theta is similar to theta 1 or theta 2?
Theta 1.
Are you sure theta 1?
Yes, sir.
Okay, you imagine. Imagine, you have to imagine. Okay. This is your flat plane. Okay, this is your plane. Okay, if you are having a kind of 90 degree, maybe no problem. Okay, because always all is about 90 degree. But if a little bit, okay, slope like this, okay, you have to imagine slope like this. So where is the normal vector for this plane? This plane, so it should be go down like this. Okay, as long as 90 degree, little bit slope. Okay, this plane normal vector like this. So let's say if okay, now the first one little bit slope like this. Okay, the second one goes up like this. Okay, like this. Okay, like this. Okay, right. Go back to this one. If you see this angle between plane here and also this horizontal plane, that is actually acute. Acute. Now, this is your normal vector and this vector. So if we are saying here, this side, the angle here, is it acute here?
No.
No. So means that this should be not similar to this one. Whereas the angle at the back here should be similar to our theta 1 actually. Okay, that's how you understand lah. Okay, between the relation of angle in our okay, between these two vectors and also between our plane itself. So basically this is our theta 2, this is our theta 1 at the back. Okay, at the back. But of course, you can give us any theta, either theta 1, theta 2, because both still represent angle between two planes. So it doesn't matter you get theta 1 or theta 2, as long as that is still represent angle between two planes, acceptable. That is the needs of our topic here, angle between two planes. Okay, so now, okay, once again, deal with the angle. We are dealing with cosine theta lah. Okay, cosine theta. So using both vectors n1 and also n2, so you just dot product n1 and also n2 divided by its magnitude, then you can get your theta. So it doesn't matter your theta is actually acute or obtuse, acceptable. All right, any question for this angle between two planes? Any question? Class?
No.
No? Okay.